Welcome to homework day 7. We're going to look at some more equations, particularly proportional relationships within an equation. And the first thing we really have to grasp is identifying equations that represent proportional relationships and the ones that don't. And this is probably one of the trickiest things, so we're just going to focus on this tonight, and then tomorrow we'll take it to the next step. Okay, so the first thing this says is to determine whether each equation represents a direct proportion. If so, identify the constant of proportionality. There's that word from yesterday. Okay, that's your K. And this is very important. Okay, to write an equation in proportional relationship form, it needs to be in y equals kx form. Okay, so last night and today in class, you were able to build equations yourself where you found K and you plugged it in. Tonight, you're going to be given an equation and see if you can move different elements around to put it in this form. So here's our first example. And it's not much different from solving equations. We're going to draw a river on the equal sign. And we want to get y by itself. So if I look at the left-hand side here, I have 1/2 y, which means I'm multiplying 1/2 times y. And in order to get y by itself, I need to divide both sides by 1/2. Okay, the 1/2s will cancel and we'll be left with y by itself, which is what we wanted. And then we have to do this 3 divided by 1/2. Okay, and if you remember, keep, change, flip, 3 divided by 1/2 is the same as 3 times 2 over 1, which is 6. And we can't forget to keep the x that was there as well. And if you want, just put this in your calculator. 3 divided by 1/2, no big deal. What I need to assess now is if this is in the correct format. So we had said over here that my equation needs to be in y equals kx form. And the equation that we have here is y equals 6x. Do they match up? I would say so. So we would say that yes, this represents a direct proportion, and our constant of proportionality, k, is this 6 here. So we say that k equals 6. Feel free to pause, rewind, rewatch as we go so that you really have a good understanding of this, and then move on to example B. Again, we're going to start by drawing our river, and we want to get y by itself. So what I'm looking at here is y minus 2. The opposite of subtracting 2 is to add 2 to both sides. So the 2's will cancel because they're a zero pair. We have a positive and a negative. We get y equals. Now over here, a lot of you are going to want to say that that's 7x, but you have to remember that we cannot combine an x with a constant. So we're just going to keep this 5x plus 2, and now our job is to assess whether or not we have a proportional relationship. So again, proportional relationships are written in the form y equals kx. We have y equals 5x plus 2, which is very, very close, except we have this extra plus 2, and the second you have anything extra, it's out of the question. So the answer here is no, this is not proportional. Therefore, there are no constants of proportionality. Go ahead and pause, rewatch, get your notes taken, and then flip the page for some practice. So on this page, you have 3 practice questions. I want you to try them on your own, and then once you finish these 3, you can go ahead and unpause the video and I'll go over them with you. Okay, so again, pause this and then come back to me so we can go over them together. Okay, at this point, hopefully you were able to try these on your own without my help, and now you're just checking and correcting your work. So for number 1, draw your river. In order to get y by itself, I have to divide both sides by 5. We get y equals 60 divided by 5 is 12. keep the x. This is in y equals kx form, so yes. And 12 is your k, your constant of proportionality. For number 2, this one's probably the trickiest one on this page. The y is on the right-hand side, which looks a little funny, and there's 2 elements here. First, we have to subtract the 1. Okay, you don't want to move the y, but you do need to remove everything around it. So we have x minus 1 equaling negative 2y. Don't forget that that negative belongs to that 2y. Then what we have to do is divide both sides by negative 2. And it's every piece on both sides. And I think that's what's really tricky about this one. Okay, so we end up getting negative x over 2. Negative divided by a negative is actually a positive. I'm just going to leave it as 1/2. No need to stress about it. Equals y. And I think you can probably tell that this is a little too messy to be proportional. And lastly, for number 3, we have 0.4 times y. The opposite of multiplication is division. These will go away and we get y equals 1 divided by 0.4 is 2.5, keep the x. And that is in y equals kx form, where k equals 2.5, which means this is proportional. When you're all set, feel free to flip the page. On the next 2 pages, you have some more practice, and these are the ones I'm going to be checking tomorrow when I walk around to collect homework. The only thing I want to note is that number 6 is a typo. It's a repeat. I forgot to change it. So rather than solving that, I'm going to ask that we do 0.2y equals 8x. So a similar problem, but just something a little different. Okay, do your best. Rewind, rewatch, look at the notes you just took, and I will go over them tomorrow. Jot down any questions you have.